All right. Anybody still writing this?
Me, sir.
So again, square numbers is numbers multiplied by itself. Cube numbers, numbers multiplied by themselves 3 times. Square root is the reverse of square numbers, and cube root is the reverse of cube numbers. And well, tables and regular tables you have to learn from, well, not one, but your 2 to your 15 times tables. I wouldn't test you on your tables, but you need to know it. And well, we did order of operation in last class. I'm gonna go through order of operation. All right. And we are going to place values. This table on the left hand side is very important in terms of your place values. Anybody still writing? Yes and no, right? All right, so place values is the next one. So place values, right? So if we give one alone, right? We need to know what the place values is. So we know that this is the decimal point. Right? And the decimal point represents where a whole number starts, or the unit starts. And then, well, on the right hand side of it will be fractions, right? So if I can draw a table going. That table might be big enough. Let me do it again. Good evening.
Yes, sir.
You hearing me?
Sir,
Yeah.
my phone going on die. It's on 7%, and I'm not home right now. I
No
talk
problem. Well, what I will do for you is I'll put the class online, right? I'll put the work online so you'll get it.
on YouTube.
Yeah.
Okay, thank you.
Right. So this is ones, this is tens, right? Hundreds. Here now is tenths, and you have to put the THS. Right? And what does really mean? This 8 right, is really 8 over 10, right? How I get that is the same as saying 8 by 1 over 10. The 9 is really 9 over 100, or 9 multiplied by 1 over 100. So the place value, right, is really 1/10 or 100th. And in this case, it will be 1 over 1,000, right? The ones, right, the 7 is multiplied by 1. So that is where we get the ones from. The tens, the 6 in this case, the 6 by 10. The hundreds is 2, so 2 by 100. And so on, right? So thousands is 2 by 1,000. Sorry, not 2. What's the value for thousands? 4. So 4 by 1,000. Right? So basically, it's this table on the left hand side. If you could draw it like this, or if I could have drawn it like this, would have been easier. But I wanted to show the place values of the numbers. Right? So the number is 1, 3, 5, 4, 2, 6, 7, 8, 9, 5. Sorry, this is a decimal. Right? So we can tell the place values of each one of these. Again, the reason for doing this is for CXC multiple choice, right? These kind of questions come, they ask, what's the place value of a certain number? Also, we need to know this when we do an approximation. So we tell you approximate to the nearest 10,000, right? Or then tell it to approximate to the nearest 2 decimal places, you know how to check it. We need to know that. Anybody still writing this? So control delete, right? So this is the base number system. I don't want to get into that as yet. I want you all to do approximation and stuff first. So let me scroll down past all of this. All of this was order of operations. You gotta go through that. We do highest common factor and we do LCM already. Fractions. Right, approximation. So we're gonna approximating to a specific place value. When we approximate to a specific place value, we look at the value to the right of it. Two scenarios. If the number to the right is greater than 5, we add 1 to the place value. And 2, if the number to the right is less than 5, we leave the place value as is, or as it is, right? So example, right? If you want to approximate 25.37 to one decimal place, you know the decimal places here. The first decimal place is 3, so that's the first decimal place. We look at the number to the right, it is greater than 5, so we add 1 to the 3. So the answer will be 25.4, right? And you put to one decimal place, right? So if you want to approximate to the nearest whole, you know the first whole value is the number before the decimal place. So you look to the number to the right, and it is less than 5. And once it's less than 5, we leave it as is, right? And again, you can also use the sign, the approximate sign. I think some people know it as this. Either one will work, right? Now there's an exception to the rule. When you're approximating numbers of objects that cannot be a fraction, you tend to round up. Example, if we cannot have 2.3 people. So we approximate to 3 people. So you can't have half of a pet or a quarter of a pet or a quarter of a person. And these things come into fruition when we're doing statistics, right? So this is something you need to learn as well. So you could go ahead and take that down. Oops, sorry. And if you're seeing it too small on your screen, you can pinch the screen and zoom in, right? So I'm gonna do a couple of examples, right, of approximation. So 6.07 to 1 decimal place, right? So the first decimal place is here. This is more than 5, so we add 1. 6.0, sorry, 6.1. 124.06981. You want 3 decimal places, so from the decimal we count in 1, 2, 3. Look at the number after it. Again, is more than 5, so we add 1 to the 9. But in this case, if we add 1 to the 9, we'll get 10. So we carry the 1, it becomes 7. Right? So it's approximately 124.070, which is the same as 124.07. This has no place value, but this one has place value. Since it is between right? So this one, this 0 has a place value since it's between the decimal point and a number with a place value, right? So yeah, I don't know which one you can erase and which one you can't. So you can just erase the ones that have no place value. 0 0.2, sorry, 0, 2, 1, 4, 5, 8. Right? So 2 decimal places. Second decimal place, we look at the number on the right. Is less than 5. So we leave it alone. 0 0.02. And all these numbers will have 0 place values after it. So you can leave it as this. And then we have to do significant figures. So when you finish, right, tell me, you could go ahead into significant figures. Right, so significant figures, we count significant figures from the first non-zero number. So in the example, 357.25 has 5 significant figures. Because we counting from 3, so 1, 2, 3, 4, 5. This one has 2 because we could only start counting from 3. This one has 4 because the first number is 1. So 1, 2, 3, 4. Right? So that's how you count significant figures.